Hey guys, Mrs. Carrillo. I am looking on the Go Formative and I see a lot of people are struggling with this worksheet. So I'm going to get you guys started on some of these in each of these sections. So if you're really, kind of struggling with the molar mass, and the mole to mole practice problems that we have for this week, then check out this video, do them along with me, and then you can hopefully get an idea about how to do the rest and get back on Go Formative to make sure your answers are correct. All right, so let's start with the first section. It's called molar mass practice. So last week we talked about molar mass, and basically it is the mass of 1 mole of atoms. So remember, a mole is the equivalent of, remember, like a dozen is 12, a pair is 2, right? A mole is 6.02 times 10 to the 23rd. So it is a very, very large number. So a mole, instead of saying, 6.02 times 10 to the 23rd every time, we can just say a mole. All right, so it is the mass of 1 mole of atoms, or 1 mole of molecules if we've got more than one atom together. So in this first section, we're just going to be using the periodic table to figure out the molar mass of certain atoms and molecules. Okay, so the first one says, what is the molar mass of potassium? And potassium's just by itself. So what you'll do is look on a periodic table. I've got one on Haiku on the homepage. I'll also put a link to the one that we use in class up on the section for this week. So I'll put that there too. But if you take a look at K on the periodic table, it is 39.10. So the decimal number underneath where it says, in the legend, it'll say like average atomic mass. That is the average atomic mass for 1 mole of atoms. So 1 mole of potassium atoms weighs 39.10. So that should be your answer for number 1. 31.90. If you want to get technical, it is grams per mole. Okay, but it should say that it's correct in Go Formative when you type in 39.10. Okay. All right, so that's what you'll do for any single element. It's pretty simple. If it said what was the molar mass of nitrogen, you look up N, and in the mass of N is 14.01, so you'd say 14.01 grams per mole. Okay, even gold. Gold has a molar mass of, where is it? It's in the transition metals, number 79. Gold is 196.97 grams per mole. So if we had 6.02 times 10 to the 23rd atoms of gold on a scale, it would weigh 196.97 grams. So that's what that means. All right, now obviously most of the chemicals that make up this world are not just single elements, but they are molecules or compounds. And so the second one, what is the molar mass of ammonia or aluminum nitrate? Okay, now we have to do some adding together. So on Go Formative, I did tell you that the formula for aluminum nitrate is AlNO3 with a 3 behind it. Okay, now what we're going to do is we're going to be just adding up the masses for each one of these different elements. So we'll add up the mass of aluminum, nitrogen, and oxygen, but we do want to make sure that we have the right amount of atoms. So remember, this 3 here on the outside is going to distribute, right? Just like we did with balancing equations, we're going to distribute that in, and we're going to be adding up 1 aluminum atom, right? 3 times 1 is 3 nitrogens. Okay, so one aluminum, 3 nitrogens, and 3 times 3 is 9 oxygens. Okay, so this is going to be a pretty big number. So when we look at our periodic table, find number 13, it's aluminum, right? You'll see that his molar mass, we only have 1 atom of that, and his molar mass is 26.98 grams. Okay, so we can just write down 26.98. And then we've got 3 nitrogens. So what we need to do is we need to do 3 times the mass of nitrogen. So that's 14.01. So 3 times 14.01, let's see what that is. 3 times, that's 42.03. Make a 0.03. Okay. And then we have 9 atoms of oxygen. Look for oxygen. He's number 8. You're going to see his mass is 16.00. So 9 times 16 is 144. Okay. So these are all the atoms separate. And how many, taking account into how many atoms we have of each in this compound. So now what we're going to do is we're going to add all of these numbers together. Okay, so we're going to add up then 26.98 plus 42.03 plus the 144, and we're going to get our final answer. So let's do that real quick. 26.98. So 213.01 grams per mole, okay, is what you should have gotten for number 2 on the Go formative. Okay, so what is the molar mass of aluminum nitrate? 213.01. Okay, so again, we just used our periodic table, added up however many atoms of each element we have. Okay, add up their masses, add them all together, and we get our final molar mass of the compound. Okay. All right. So you're going to do the same thing with number 3, H2SO4. Add up 2 hydrogens, 1 sulfur, and 4 oxygens. Right. And then for the mass of sugar, for number 4, you're going to add up 12 carbons plus 22 hydrogens plus 11 oxygens. Add that all together for that molar mass of sugar. All right, so that was our first section for this practice on Go formative. The second section is our mixed mole island practice. So this was, again, what we did last week in converting between moles and grams and moles and atoms, right? So we have 2 different conversion factors for this. So we know that 1 mole is equal to 6.02 times 10 to the 23rd atoms, right? Or molecules. And we also know that 1 mole is equal to however many grams we see on the periodic table for that element or compound, right? So those are the 2 conversion factors we'll be using. If it's asking us to go from moles to atoms, we'll be using our first one, right? Where we have 1 mole equals 6.02 times 10 to the 23rd atoms or molecules. If it's asking us to go from grams to moles, we'll be using our second one, because that one tells us how many moles or how many grams are in a mole of a particular substance. Okay, so let's see how this works for numbers 7, 8, and 9 on the Go formative. So for those ones, it's going to be 3, 4, and 5. So this one is 7. Oops. This one here is 7, 8, and 9 on the Go formative. So let's set up each of those to make sure you guys are doing these ones right. These 3 are the most missed ones that I've seen so far. So number 7 says there are 2.43 times 10 to the 46 molecules of water in the Pacific Ocean. How many moles of water is this? Okay, so we're given molecules and we need to find moles. So that means we're going to be using this conversion factor right here, the top one. 1 mole equals 6.02 times 10 to the 23rd molecules. All right, so what we do is we always start with what we're given in the question. In this case, it's 2.43 times 10 to the 46. So we're going to start our calculation with that. 2.43 times 10 to the 46. This is molecules, right? And then we're going to set up our conversion factor. And to convert between moles and molecules, like I said, we're going to use that first top one. And we need to make sure that whatever our beginning unit is, in this case it's molecules, that it is on the bottom of our conversion factor so that it will cancel when we do our math. Okay, so that means molecules needs to go on the bottom so they'll cancel. Okay, and then we're gonna have moles on top. Okay, so you'll just notice that in my conversion factor, what I did was I did the units first, and that's super important. So please don't forget to put units down when you're doing your conversion factors. If you're just trying to put numbers in places, you're going to confuse yourself. You're going to be like, okay, do I put it on top or bottom or what? If you put the units down first, then you can put the numbers in, okay? And you'll know exactly which number goes on top and bottom. So in this case, our mole unit is on top, so we need to put 1 for mole, because in our conversion factor, 1 is associated with mole. And then on the bottom, we need to put our 6.02 times 10 to the 23rd. Okay, that's going to be our number on the bottom of the conversion factor. So once we have everything set up, we're going to multiply on top and then divide by the bottom number. Now this is super important. I think a lot of you are getting this wrong because you're not using the parentheses on your calculator. You definitely need to make sure that you use parentheses when you're using the 6.02 times 10 to the 23rd. Okay, big, huge numbers. In fact, I would put this front number in the calculator as well. Right? If you don't put them in parentheses, your calculator is going to do the order of operations incorrect, and you're going to get the incorrect answer. Okay, so make sure you use parentheses around big, gigantic, scientific notation numbers. So if you put 2.43 times 10 to the 46, and times 1, obviously, is just 2.43 times 10 to the 46, and then you divide that by 6.02 times 10 to the 23rd, you're going to get 4.04 moles. Okay, so there's 4.04 moles of water molecules in the Pacific Ocean. Okay. Now this makes sense. Moles are, remember, it's a counting unit for a large number. So 1 mole is a large, is 6.02 times 10 to the 23rd. So that means 4 moles, okay, is an answer that makes sense in this case. Okay, so we divide 10 times 46, 10 to the 46 divided by 10 to the 23. That's about 4 times. All right, let's take a look at number 8. It says there are 0.011 moles of potassium in an average banana. How many atoms of potassium are in a banana? Okay, so again, in this one, we are given moles this time, and we have to find out how many atoms there are. So looking at what we need to convert between, we need to convert between moles and atoms. So again, we're going to use that top conversion factor. 1 mole equals 6.02 times 10 to the 23rd. So we're going to set this up by starting with what we're given. So in our question, we are given 0.11 moles of potassium. And then we're going to have our conversion factor, where we want to make sure that the moles cancel. So that mole to cancel, it has to go on the bottom. Moles of K on the bottom, so that they cancel. And then if the moles are on the bottom and we're using the same conversion factor, that means atoms is going to be on top. And this time, we are going to have 1 mole on the bottom and the 6.02 times 10 to the 23rd on top. Okay, so when we do this math, we're just going to do I forgot a 0 there, 0.011 times 6.02 times 10 to the 23rd. Okay, and again, put that in parentheses so you know your calculator does the order of operations correct. Okay, so if you do 0.011 times 6.02 times 10 to the 23rd, you should get 6.62 times 10 to the 21 atoms. Okay. On your calculator, please don't forget the exponent, okay? Anytime you have atoms to end with, you need to have a gigantic number because atoms are super, super, super small. So you're never going to have an answer that's like 6 atoms or 7 atoms, all right? It's always going to be times 10 to the something power. So make sure you're looking at your calculator carefully when you're doing those types of problems. All right, let's take a look at number 9 under the mixed problems. It says if 16 grams of sugar are in a spoonful, how many molecules of sugar are in a spoonful? Okay, we have to be real careful with this. In fact, to give a hint on Go Formative, that you're going to have to do 2 calculations for this because we start with grams and we end with molecules. And if you look at our conversion factors, there's no grams and molecules. There's no something grams equals something molecules. Okay, in fact, the go-between for both of them is moles. So what we're going to have to do is we're going to have to go from grams to moles first, figure out how many moles of sugar that is, and then we can go from moles to molecules. Okay, so we're going to need 2 conversion factors for this problem. So let's see how this is going to pan out. So we always start with what we're given, 16 grams of sugar. That's our C12H22O11, right? And the first thing we said was we need to convert it to moles. So we need to get rid of grams. So we'll put grams on the bottom of C12H22O11. And we're going to put moles on top. Okay, that way we get rid of these gram units, right? So, according to our conversion factor up here, 1 mole, so the 1 goes on top with mole, is going to equal whatever grams it says on the periodic table. Okay, so what that means is we have to look up on the periodic table, we have to count up the mass of 12 carbon atoms, right? Plus 11 hydrogen, 22 hydrogen atoms and 11 oxygen atoms. So on our calculator, we need to do 12 times 12.01. Then we add 22 times 1.01 for the hydrogens. And then we'll add another 11 times 16 for the oxygens, and you should end up with 342.22 grams. Okay, so that's how many grams are in 1 mole of sugar. So we went from grams to moles, and now we have to do the last step going from moles to molecules. So we can now add a second conversion factor where we're going to put moles on the bottom so that it cancels the moles there. And we are going to put molecules on top. And in this case, we're going to use our conversion factor up here, the first one. 1 mole equals 6.02 times 10 to the 23rd molecules. All right, so moles is on the bottom, so our 1 goes on the bottom. And then 6.02 times 10 to the 23rd goes on top, because that's the number of molecules in a mole. So when we do this and we do the math, we multiply 16 times 6.02 times 10 to the 23rd, and then we divide it by 342.22. Okay, we're going to get a gigantic number because remember we are ending with molecules. So we're going to add some number times 10 to something power. So let's do that real quick. So you'll end up with 2.81 times 10 to the 22 molecules. Okay, so that's should be the answer for number 9 on the Go Formative. Okay, so there's I did 3 of them with you in that section. You can do the other 3 on your own, making sure you're using the right conversion factor and putting the units in the right spot as you're converting, making sure the units cancel as you go along. Now let's take a look at the mole to mole practice. Okay, for this mole to mole practice, the first thing you need to do is balance each equation. All right, so just like we learned earlier in the semester, you're gonna make the little atom inventory and balance each equation before you even start each of these practice problems. So we're gonna do the first two together. Okay, the copper and silver nitrate one, as well as the methane and oxygen one. So I'm going to take a second and balance those two, and you can check yourself. All right, so for the first one, we just needed to put a 2 in front of AgNO3 and a 2 in front of the Ag on the product side. So now we're all balanced, and we can take a look at these questions here. So remember, mole to mole, basically what we're doing is we're thinking about these equations as kind of like a recipe. So in the s'mores lab that you guys did earlier, you guys were working with, the recipe for s'mores. 2 graham crackers plus 1 marshmallow plus 2 chocolates equal a s'more. And using the ratios within that to figure out how many s'mores you could make. So like if you had 10 pieces of chocolate, then theoretically you could make 5 s'mores, right? Because, 2-to-1 ratio. Same thing here. In this equation, it's like a recipe. 1 mole of copper plus 2 moles of silver nitrate is going to make 1 mole of copper nitrate and 2 moles of silver. So it's just like a recipe. So what we're going to do is we're going to use the coefficients, just like we did in the s'mores lab, as ratios between the two. So like in the s'mores lab, when we had, oops, no, we do not have 5, silly teacher. When we had 2, right, chocolates that made 1 s'more, that was a 2-to-1 ratio. 2 chocolates per 1 s'more. So same thing here, if we're talking about, for example, let's actually jump down to 1b, where it says, what is the mole ratio of copper to copper nitrate? Well, both of them have a 1, so this is a 1-to-1 ratio. Right? And C says, what is the mole ratio of silver nitrate to copper nitrate? Well, here we have a 2, so it's 2, and then here we've got a 1-to-1, so it's a 2-to-1 ratio. Okay, so we're going to be using these ratios as conversion factors. So instead of using the 1 mole equals 6.02 times 10 to the 23rd atoms, or the 1 mole equals however many grams on the periodic table, now we're going to be using this new conversion factor of the coefficient of one is going to, be equal to the coefficient of the other. Okay, so for example, 2 AgNO3s is going to make 1 CuNO3. Okay, so these are going to be our new conversion factors. So let's take a look at 1a. So it says, how many moles of copper are needed to react with 6 moles of silver nitrate? So we always start, just like on all of the other problems, we always start with what we're given, 6 moles of silver nitrate, and that's our AgNO3. So we start with that, and we're going to have to get rid of these moles of AgNO3 and convert them to moles of copper. So moles of AgNO3 go on the bottom so that they can cancel, right? And then we want to find moles of copper, so that goes on the top. Again, just like I did earlier, I put the units down first, then I'm going to put numbers. That's the only way you're going to do it right. Okay, so please don't cut any corners with this. Make sure you put the units down first and then put the numbers. So the numbers come from the coefficients. In this case, we have to ask ourselves, what is the coefficient for copper? So in our reaction here, the coefficient is just a 1. So 1 goes on top for copper. And then what is the coefficient for AgNO3? Well, that's 2. So 2 goes down there for AgNO3. So again, with this mole to mole, it is we're looking at the coefficients for the conversion factors. Okay, so 1 mole for copper and 2 moles for AgNO3. And then just like we've done before, we're going to multiply on top and then divide by our bottom number. So 6 times 1 is 6. 6 divided by 2 is 3. So our answer should be 3 moles of copper for that one. Okay, so in your Go formative, if you got that one wrong, hopefully you understand why. Okay. Now let's take a look at the second one. This is the last one I'm going to do with you guys, and then you guys are going to have the rest of them to do by yourself using this same kind of setup. So remember, please don't forget to balance each chemical reaction first. That might be what is going wrong. If you're setting everything up right and you're like, yeah, that's what I'm doing, Miss Creo, and you have nothing but 1 and 1 ratios, that's your big red flag. Okay, you didn't balance the chemical equations first. So go back and make sure you do that, and then you can reinsert those coefficients for your conversion factors. Okay, so the second one there says if 5 moles of ethane, that's our C4H10, are used, how many moles of water are produced? Okay, so again, we always start with what we're given. So 5 moles of our C4H10. That's really bad. There we go. All right, and then we're going to put our conversion factor. We need to get rid of these moles of C4H10. So that means on the bottom of our conversion factor, we're going to put moles of C4H10. Okay. And then on top is what we need to find. In this case, it is moles of water. So moles of H2O go on top. So see, we have moles of C4H10 canceling out. Moles of water is what we're left with, which is exactly what we're trying to find. Okay. Now, once we put our units down, we're going to put the numbers from our coefficients. So we have to look and see what is the coefficient for water. In this case, our coefficient for water is 10. So 10 goes there on top. And then what is our coefficient for C4H10? Well, that's 2. Okay, so the 2 goes down on the bottom. So now we do our math. 5, the top, multiply the top, divide by the bottom. So 5 times 10 is 50, divided by 2 equals 25. So 25 moles of water can be made with 5 moles of ethane. So that's your answer for the second one. Okay, so hopefully that helped in getting started with the rest of these practice problems. If you already submitted it, you should be able to go back and fix your answers. I made it adjustable so that you can edit it and go back and fix your answers. So please do that so you understand what is going on. Okay. All right, so otherwise, good luck, and email me or post on the discussion board if you have any other questions.